what excites me about AI and software engineering is when you combine those two things together, where humans are flawed, but LLMs are equally flawed. But when you combine them, you can do incredible things with the two of them.
Welcome, Owen. Really excited to talk to you about AI today. As we just talked about beforehand, it's a very polarizing topic.
Yeah.
And you've really doubled down on focusing on AI engineering in the last year or so. So to your mind, what is an AI engineer? And what are you focusing on as you study that?
It's a good question. I think it's one of those terms that can be fairly loosely defined. So in my mind, an AI engineer is simply someone who is building software with AI, so building production systems using AI. And so on one extreme, you have people who build AI models, they train the models. On the other extreme, you have a software engineer who builds software. And an AI engineer kind of fits in the middle, to my mind, where they're largely building software systems, but they're also using AI within those systems. So there's a lot of crossover. It's like with all of these roles, right? There's just a ton of crossover. But I think there's a lot of things you need to know when you're working with AI. It's a very different paradigm, a totally different way of working. You need to know, how do you test these things? How do you architect the systems so that they're reliable and scalable? And I think that knowledge takes a while to learn. So I work with a lot of software engineers, and a lot of them start building with AI, and then they hit a lot of issues early on, because I think it requires a lot of just knowledge about how to architect these systems for scalability. Again, testing them, knowing which models to use, what the trade-offs are, and then also when not to use AI as well. I think that's kind of the interesting thing with AI systems in my mind, is that a lot of the things you build with AI, you want to use AI in the most minimal way possible. You want to use it where it makes sense. And there are many applications where AI isn't the right choice. So just knowing all of those things and being able to make those trade-offs and being able to build useful things with AI is how I think about AI engineering.
Okay, so you're very much thinking of you're building a product with AI in it as a primary definition of an AI engineer.
Yeah, and it could be a product, or I like the word applied AI. So taking the models we have, and if you just use AI, just using ChatGPT, it's fine, it's useful, but actually building real systems with these tools, I think that's how I think about AI engineering. So building workflows, automation, systems, or building AI into your product, those are the things I think about.
So in your focus on that, have you been focusing on all of AI, like the whole massive field of AI, or primarily around the kind of LLMs and what's really been hot in the last couple of years?
That's a good question. So for me, my interest personally is around LLMs. I think largely what's happening now, I think all of that, the wave right now that we're seeing is all about large language models. Obviously, there's multimodal AI, and there's many ways you can bake AI into your systems nowadays. So you can have image recognition tools, you can have video processing tools. So largely it's the generative AI stuff, which I think that I'm personally most interested in, because it's a thing we've never had before. And I'm interested in how we use that to build better systems, better processes, how we use it as software engineers. So largely it's the generative AI side that I'm most interested in.
Okay, cool. Just wanted to narrow that down, because there's somebody that's been interested in AI for 40 odd years, which makes me feel very old. And it's what got me into software engineering. I still bristle a little bit that AI, is this massive field, has been reduced to this one application of it in LLMs. So just good to set the scope of what we're talking about.
Yeah.
Okay, cool. So what do you see as a really good example use case for an LLM?
So the most obvious use cases that I see are in a business application would be something like, well, there's a couple of categories of systems you can build with AI. And I think that's why it's interesting. It doesn't mean you can apply AI to everything. There are many places where AI just doesn't make sense, right? But the most common thing that I see are things like natural language interfaces to information. So for example, in our company, this is the obvious use case, right? You have a large number of documents, you have HR policies, you get users in a large company. You have thousands of people in the company asking the same questions over and over again. So things like HR policy support bots or IT assistant bots, those are some of the most common, but then also just business automation. So document processing, things like that. And I'm also interested as well, personally, I've been really excited about the topic of applying AI in software engineering itself. So in operations, because I think that's largely an area where people don't talk about that very much. But how can you use AI as an on-call software engineer is an area I spent a lot of time. You can use AI to process large amounts of information, searching through thousands of log files and identifying issues, and using natural language to make our workflows more efficient. So rather than manually going to 5 different logging systems and pulling out that information and manually searching, you can just talk to like a conversational interface and just say, go and fetch me all of the logs and diagnose this incident, right? That's an incredibly powerful interface to any software system.
So that's a really interesting one. And I spoke to some engineers building a similar use case in a way in that they were collecting information from the web and asking the AI to basically parse this information, extract some data from it, and give them what ultimately boiled down to a yes/no answer. The benefit potentially of an LLM there is they were able to do something at scale that would be impossible with all this unstructured data without an LLM.
Yeah.
The risk I see with that is these things are non-deterministic, partly by design and partly because of the nature of how they're built. So how do we marry that? We've got something that's fundamentally non-deterministic with we want a business process that I guess ideally should be deterministic, but we could make a reasonable argument that even a human being doing it is not going to be deterministic. They're going to make mistakes. They're going to have an error margin. So how do we marry that to? What's your approach and thoughts on that?
That's a brilliant topic. And I think that gets to how I think about AI engineering in terms of architecture. So there are 2 kind of extremes of AI systems that I see. One would be the far extreme would be something like an AI agent where it's autonomously deciding what to do and it's making tool calls and you give it a task and it will go off and do that. And it's very non-deterministic, right? Those things are very unreliable. So despite there's a huge amount of hype about AI agents, they're a terrible solution to many problems because they are so non-deterministic and so maybe unreliable is the right word. And then the other extreme, you can build workflows where you're using AI in a very, very minimal way. So you can have, structured workflows where I'm only using AI to classify a yes or no answer. And so you can constrain the AI as much as possible. And I think the reality today, I think a lot of the systems that use AI well are using that workflow type approach where you're really constraining where you're using AI. You're not using it for everything. You're maybe taking a large document and bring it into like a structured output, or you're using it for classification, but you're only using it in like part of your system. And even in the AI agent case, the thing I like to think about is that the AI agent example is largely just calling deterministic code. So what I mean by that is when you build an AI agent, the AI agent is making a decision about what to do, but the tools that you give it can be very, very deterministic. When I was talking about software operations as a great example, though it doesn't make sense to use an AI to execute certain dangerous commands, but you can put guardrails in place. So you can have approval steps, for example. So before I execute this command, you can give it to a human to approve that step. So I think the best use cases for AI are largely human in the loop, where a human is approving many of the things that the AI does. And then that way you kind of get the best of both, right? You get this powerful system. The AI can do incredible things. It can execute deterministic, complex code for you, but you can also have an approval step as well. Does that make sense, John?
Yeah, absolutely. And for a lot of software engineers who may be experiencing this through actually using AI to code, a lot of the coding agents are like that in that, I just tried Augment Code recently. That's a great example of one that will put up, say, I want to do this. Do you approve? So you've got that human in the loop check and you have that ability to stop or go at every point.
Yes.
Which I guess brings us whole to an interesting topic. Everyone's claiming that all code will be written by AI
Yeah.
within the next,
Yeah. I
well, I
think
think it was 6 months ago, all code was going to be written with AI, and there'll be no need for software engineers. I don't for a moment think that's true.
yeah.
I've heard it at least 4 different hype cycles around that in my career, or in my lifetime, rather. I haven't been coding since I was 8, so not professionally. So I don't believe that, but what are your thoughts? Where do you think the kind of boundary lies?
I love this question. I think as we were talking before this call, John, about the kind of the polarizing extreme views here, and obviously you hear those statements. I know you called out yourself as the Anthropic CEO saying 90% would be written by AI. I think there's always nuance with those statements. And although a lot of that is marketing hype, I think where he's coming from is that inside Anthropic, I think a lot of their code is written by AI, and certain types of things you can write a lot of code with AI, but there are many situations where you can't. So I think it's not a black or white thing that you can write large amounts of code with AI in every case, but in some cases you can. So to give you an example where I love this use case, right? Internal tooling is a thing that developers all build. We all build CLI tools and custom code for our own use cases. In that case, you can 100% vibe code or fully use AI to generate that code because the risk of getting it wrong is lower. So the barrier of quality is lower. You obviously want to test that code, but to a degree, a CLI tool that you use for yourself, for your own use case, is not the same as a system that is used by millions of users and it's critical. So I think there's a lot of nuance in when we say I can use AI to 100% build things. I believe you can because the example I would give is I had a tool that I built to process video. So and there was another example where I was going to buy a SaaS tool. I think it was $500 to buy a SaaS tool. And I was able to build largely the same thing myself through vibe coding, 100% AI generated. And it solved my problem. The code worked. It wasn't battle tested. It wasn't the most secure. The code was not perfect, but it worked. And so in that case, you can use AI. But in most real situations, which I think was what you're talking about here, John, which in reality, can you AI code everything? No, not at all, because humans still need to review every single line of AI generated code if you're using it in a real situation. Does that make sense?
Yeah, absolutely. And I'm not letting we're not letting Dario off the hook at all. I still think he's absolutely full of it there.
Yeah.
Because his statement was that eventually, within, I think it's been 12 months, all code would be written by AI.
Yeah.
I think that just shows what what's the phrase? Basically, it shows his lack of experience, and he has done less than 2 years professional experience writing code. And it shows that he has no concept of what code is like in the real world. And I absolutely agree with you. You can build things 100%, and I have vibe coded an entire website. I wanted to build a website. As you say, it wasn't mission critical. I thought it'd be cool to learn Astro to do it, and I suck at doing websites and CSS and front end because they end up looking like my 5-year-old drew them. So, yeah, in this case, I used Claude to do that website, and it wrote all the code, all the CSS, and it looks way better than if I'd done it. So, yeah, great. However, to say that you're going to write 100% of code means that you really have no concept of what a huge part of the code in the world does. You are just thinking of websites, and fairly simple ones at that. You are forgetting that there's code in spaceships, there's code in aircraft, there's code in air traffic control systems, there's code in trains, in signaling systems, there's code in medical devices. Very little of that code is in the training data because it's all proprietary and protected. Very little of it is going to be suitable for this kind of training. And the things that you have to go through to make safety critical code where people's lives depend on it are incredibly strict. And we're not going to have vibe coding in that for a hell of a long time. And, that list of software is massive. We forget that, of the 27 or so million software engineers there are in the world, probably less than half of them actually work on web stuff. Yes, they get all the noise and all the hype, and it's what's talked about, but there's an awful lot of people building embedded systems and building, as we say, nuclear power plants and all that kind of stuff that has a very different approach to software engineering to us knocking up JavaScript on the web.
I completely agree. And I think the way I like to think about AI coding is how can we use AI to build better and more secure software? And I think the examples you just gave are great, right? There are certain places where you cannot just rely on AI to build your code. But one thing that I'm excited about myself is using AI to make better quality software. So code review is the kind of thing that never gets talked about very much online, but AI is fantastic at code review. It can spot errors in software that humans simply cannot spot. And so when you combine human plus AI, I think we end up with better software. But I think you're right. There are very few cases where you can have AI fully generate code. But I do think when you have AI as an experienced software engineer who knows what they're doing and who is fully guiding the AI and reviewing every single line of code, I believe you can produce better software than you could without the AI, if that makes sense. Code review is a great example where AI can detect bugs that would go missed by a human code reviewer. So that's how I like to think about AI coding. It's how you can use AI to make yourself as a software engineer better at your craft, how you can solve problems faster, how you can find bugs in your code, find mistakes in your thinking, find architectural problems. That's how I like to think about it. But I 100% agree. Just fully replacing software engineers is not a thing that I think will ever happen, because no matter how good the AI tools get, and they are getting better all of the time, you still need to know what you're doing. I 100% stand by that. AI is just a tool, and it's a tool that you use as a software engineer, but you need to know how to work with the tool and when to ignore the tool's output, when to disagree with the tool, knowing how to guide it and what information to give it. So it's 100% dependent on the skill of the person using the tool, is my opinion.
Yeah. You mentioned code reviews there, so I really want to pull that thread. Because for want of a better word, I completely disagree with you, and I completely agree with you at the same time.
Yeah.
So I completely disagree that AI is going to be better than a human at spotting bugs in code review, because LLMs are not intelligent. They don't have the ability to reason. They can't step through the logic and identify things. So I completely disagree for that reason, that they can ever be better than a human at a code review. Of course, I'm picking the ideal human there. The reality is, how many times, and it's even a meme now, do you see a code review that says LGTM?
Yes.
Yeah. So a human potentially is better than an LLM will ever be, because LLMs don't reason. But I probably think the LLM is better than the average human code review,
Yeah.
because it doesn't have to reason. And I've tried CodeRabbit on some code bases I have, and it picked out things that I missed.
Yes.
Yeah. Partly it's don't review your own work. It's really terrible because you don't see the wood for trees. Partly it's because a couple of things I didn't know about, and partly it's because I was so focused on something else. I just, I'm human. I miss that thing. And code reviews are really, really hard to do well. There's such a thing that all of the human biases and the reasons that we fail just comes light to the fore. We're terrible at it, which is another reason I think that actually having LLMs generate thousands of lines of code is a bad idea, because we're not going to review it well. But yeah, I think code review is an underrated and under-focused on area for us to really say we can leverage AI, because then it doesn't have to beat the best human. If it beats the average code reviewer, it's adding value, isn't it? Because
yes, 100%.
Then if we catch 50% more issues in code review than we are now, that's a productivity game. That's a quality game.
I think you nailed it there. I think that's the key point. I kind of agree, and I also disagree as well. I think
Cool.
we're in a similar position where I believe there are things that machines are better at than humans. So to give you an example, I used to program in Haskell, and the compiler in Haskell, if you've ever used it, is incredibly good at spotting logical type errors in a way that humans can't see them. But it doesn't mean that you can replace your thinking with a compiler. But I believe that machines are good at certain tasks that humans aren't. And equally, I believe the opposite, where machines will never replace human thinking. So using your code review example is a great one, where I think we're saying the same thing, where the LLM will detect issues that a human might miss, and a human will see things that the LLM will miss. Because a human has context. We understand the business. We know why this code review exists. We know what customers need. We have all of the context that the LLM doesn't. but the LLM can blindly look and it can see errors that I frequently find it spots things that I would miss, for example. So sometimes those bugs could be critical. So I think we're probably saying the same thing where you need both. If an LLM can catch 50% more bugs than without one, why would we not be using the tool?
Yeah.
Why would we not use this tool? It would be insane. It would be, I guess, it would be non-professional to not use that tool, right? Because it's just a tool that can spot bugs. And going back to the operational example, in for example, when diagnosing a Sev2 at 2 a.m. as an engineer in operations, I was able to detect like root cause a bug by giving it to an LLM, and it was able to find a thing that I just missed as a human. I couldn't see it in all of the log data. And so that's a great example where you can kind of use both, right?
Yeah, absolutely. And we should probably stop trying to compare things as what's the perfect scenario. Because, like I say, as humans, we miss things in code review. The LLM will miss things. Let's say we catch on average 50%. If the LLM catches 50%, we've got a choice then. We can use both to catch more, get an incremental improvement, because 50% and 50%. It's not going to add up to 100%, but we might get, I don't know, failing my stats maths at the moment, but we might get to like 70% of the bugs get caught, depending on the overlap, which is an improvement. Alternatively, if we're happy catching 50% of bugs in code review, we could use a code review tool and free up the human to work on other higher value tasks that perhaps earlier in the process would stop those defects getting to the code review stage anyway.
I think this is where maybe the hype comes in with AI in general, in that AI is flawed. Like using LLMs to review code, like you just said, there are places where it's flawed and it doesn't work very well. And I think the right way to think about it is to accept those limitations and also accept that there are areas where it does a really good job that is sometimes better than a human would do, but equally, in many cases, a human would do a better job. So humans are flawed in many ways. We miss things, we get tired, we aren't thinking clearly. We need someone to help us think better or spot things that we might miss. And equally, an LLM does the same thing. It doesn't have the context that you do. It'll make a mistake. But when you combine those two things, I think that's what excites me about AI and software engineering, is when you combine those two things together, where humans are flawed, but LLMs are equally flawed. But when you combine them, you can do incredible things with the two of them.
Yeah, and by that nature, compilers don't catch all the errors, hence we still have some.
Yeah.
But a compiler does catch some, hence why we benefit from using them, as well as the fact they compile our code.
Exactly.
Linters don't catch all the errors, they're not perfect, but they do catch some, so again, we use them. If we add all these tools together, we get layers of improvement. We do get a benefit from it.
Yeah, exactly. And I think that's the hype problem, I think, in a nutshell, where people want to take these to extremes and say, well, AI can write all of the code or AI can find all of the bugs. And obviously it can't, but it can find some that you would miss. I like to use the word, it's just another tool. And it's a very good tool. It's probably the best tool I've ever seen in my career as a software engineer, but it still has limitations and it still has a lot of downsides.
Yeah. And I think one of the things that it has huge potential for is as an amplifier. So if you know something well, if you're capable of doing something well, I'm building software, all other areas. I mean, LLMs are useful for other areas of writing. So, writing a blog post or writing a novel, it has the potential to amplify the skills you have and the quality of the process you have.
Yes.
On the flip side, if those skills and those processes are not so good, it potentially amplifies all the bad things you're doing as well. Yes. And I think that's getting lost in, I've seen 7 or 8 social media posts in the last 2 weeks, as well as various podcasts where people have claimed that they are producing 13,000 lines of code or 12,000 lines of code or 15,000 lines of code or whatever crazy number it is of production code every day with an LLM. Staggered when I see that, especially as some of these are fairly well-known engineers who have a very good reputation. But I'm staggered when I see that, thinking, yes, I can see how it can amplify the effectiveness of an engineer, and as we said, amplifies the negative result of what you do. But what I can't fathom and get my head around that is I can't imagine going, let's say, a week, producing, let's say, just a modest 10,000 lines of code, 50,000 lines of code in a week. And bear in mind, I normally work on back-end systems, so I'm not talking of thousands of pages of CSS or React framework. I can't imagine producing 50,000 lines of code of production quality, purely because I can't imagine having enough requirements to feed in every day to generate 10,000 lines of code, because the bottleneck, or the upstream bottleneck from that, to me, has always been getting the requirements and being able to clearly specify what we're going to build.
Yeah.
And I was thinking about this recently, and at one job where I can say that I contributed tens of millions of dollars a year in value, I think my average output was 10 lines of code a day.
Yeah, and that sounds pretty normal to me.
And there were 1 or 2 days where I think I maybe did 1,000, 2,000 lines of code.
Yeah.
But most of my days were spent going, what should it do? How should it do it? What's good look like? Then how the hell do I document that clearly and unambiguously in English? So we write it down and we agree on it and we agree what the acceptance criteria is. And there might have been weeks at a time where I didn't write any code because we were going through all that hard analysis. So I can't imagine having enough of that happen that I can produce 10,000 lines of code a day. What are your thoughts on how, what's your experience been like that? Do you feel that that bottleneck exists? And I guess the follow-on for me is, I'm kind of curious as why we're not talking about how we can use LLMs to address that bottleneck, which has always been the bottleneck as far as I'm concerned. Because I think they can ask us questions. They can prompt us for requirements. You can do a brain dump of here are all my requirements, structure this in clear and ambiguous. They can be really useful for that. I've tried doing that to process things, and it's been very productive. But I don't see many people talking about that. So do you feel that's a bottleneck? And do you think we're missing out on using LLMs to tackle that bottleneck? If you agree, it is
100%. And to go back to your point about generating thousands of lines of code, as a senior engineer, one of the things I'm always most proud of is removing code and simplifying code. So I think that gets missed. But I think there's a lot of nuance. It depends what you're doing. You can generate thousands of lines of code to generate a prototype quickly so that then you can test and ideate faster and identify bottlenecks. Then you can take that back to the design stage. The other things I don't hear people talk about much is you can use AI to do what we just said, which is to remove code. So you can use AI to simplify. So my personal workflow is often to generate something quickly, find out how it works. And then once I understand, I will go back to square one again and rebuild or simplify or remove code and bring it back down again. I think that's an important part of the overall workflow. But to your point about using it to get past those bottlenecks, I do agree. I think you should use AI in every part of the software lifecycle to improve that lifecycle. So planning, ideation, simplifying designs, improving architecture choices. You can ask AI to give you feedback on your technical designs. And in where I work in an enterprise environment, it's not uncommon for a project, even a simple feature, 6 months of work. And that 6 months is a huge cost to a business. So that involves planning, detailed requirements gathering, designing a really detailed architecture document that goes through every single possible edge case and cost analysis. Then it comes on to building, and then you have a testing phase. So I believe you can use AI every single part of the life cycle to do a better job. And again, I think it's not about replacing humans anywhere. It's just about how can we review those designs and spot errors, or how can we improve the stories to make them more clear? As you said, like the user requirements, a great use case of AI in my mind is reviewing requirements and simplifying them so they're easier to understand, or spotting mistakes in the requirements and things like that. So they're not things that get talked about, and those are small use cases, but those things do add up, I think, over time.
Yeah, absolutely. Again, I've sat in enterprise environments, a similar thing, and where you've produced RCs or PRDs or whatever jargon you use in your company. What I don't see anyone talking about is having set up a chatbot and said, your role is to be a senior architect. These are the typical questions that you should ask about this architecture. This is an example. This is some past reviews we've done. This is the example questions that came from it. Now, here's my RFC or whatever. Critique it for me. Where could I improve it? How could I tighten it up? That, to me, is an incredibly powerful use case. If you can do that, we're back to the code review thing. If you can do that review and iterate on that 3 or 4 times with an LLM, Again, it doesn't matter if it's not perfect. If it asks you a bunch of questions and make you improve your thinking, tighten up your document. So you then go and present it to the real life architecture board or whatever you're dealing with. And it's a much tighter document that's now 2 pages, that's gone through that 4 or 5 stage. You don't have that really stupid question that you put it down and somebody else reviews it and immediately says, oh,
Did you
what
consider
about
this?
Yeah,
Yeah.
because you've been through that and the LLM's done it. So you can go and make far better use of that board. I don't see people talking about those, and I'm not really sure why. Because again, making a coder produce twice as much output as one person producing twice the output. That architecture board in the last enterprise I was in was 20 people.
Yeah.
Sitting down for an hour every week to do these reviews. If you cut out, that time, that's 20 people, a very senior people that you save. That would be a far greater leverage, I think.
I think you're right. I 100% agree. I think using AI in those places probably is even higher leverage. An example of something that we do in our company is we have an AI API review board where we review API designs. So the architecture of your API, does it conform to the right standards? We have a very extensive, it could be 20-page document of all of the API standards that has to return this status code under this condition. And so we have a team of people whose job it is to review changes to API schemas, essentially. And that can take a day to a week to do that work. And that's a great place where you can encode the rules and the how you should review this API into a structured guide for the AI. And it can do that guide and pretty much do it in 5 minutes. And that's a really high leverage thing, because again, it'll spot things that you miss as a human. It's very difficult for us humans to keep a 50-page design guide in our heads. It's very easy for a machine to do that. So I think that's a really great use case.
So again, I wouldn't totally trust it on that. Mm-hmm. I would still assume that it's going to get it wrong, but I bet the human reviewers do.
Yes.
And the other thing is, as you say, if it does it in 5 minutes, you can go through that 3 times yourself before you go to the board.
Exactly.
And then you're far more confident you're going to pass the board first time. You take up less of their time in that way. So again, it's massive leverage, isn't it? And I don't know why we don't see more people talking about that. So as we're kind of in this area, there's been a little bit more talk recently about spec-driven development. What's your thoughts on that?
So when we talk about spec-driven development, we talk about moving beyond giving, the beginner way of using the AI agents like Claude Code and these new tools is to obviously give it a minimal textual prompt and go write a test. With spec-driven development, we're giving it a lot more context, and LLMs are only as good as the context we give them. They're flawed in terms of if they do not have the context, they will do a bad job. So I think it's a good way to design software. I do think it doesn't matter that much. There's a lot of new tools available for spec-driven development, but ultimately, the LLMs are just being given the right information. And so whether you've got a structured specification or a markdown specification I actually don't think it matters to the LLM, but it helps the human think more clearly about what am I asking the AI to do. And again, I think it comes down to software engineering best practices, right? When we build software, we want to design up front first. We want to think it through really, really carefully. And I think that's the right way to design software with AI, is to really carefully plan your tasks first, then give it. So Claude Code has a great planning feature you may have seen, where the best way to use these agents is no longer to just say write code. You iterate for maybe 10, 20 minutes. The AI will write an extensive plan. You will extensively review that specification and the plan. Then you implement it. And I think that separation of thinking, human thinking plus the AI thinking, then the execution, I think that's the right way to use these tools.
I absolutely agree. What I find really interesting about this move to spec-driven development with AI is I have long been an advocate of extreme programming and test-driven development. And one of the biggest pushbacks I see against that is people saying, well, I can't do TDD in our company because we got to move fast and we don't have the requirements and we don't know what they are. And you can only do TDD if you know all the requirements in advance, which I think is absolute rubbish, because the whole point of agile and extreme programming was to tackle the fact that we didn't have requirements and we couldn't do waterfall, because when we try and do the requirements in advance, we very rarely get it right. And all back to humans make mistakes. It's really hard to do. And the world changed around us. So we went to Agile, where we work with a customer and we get the requirements kind of just in time. And the point of TDD and XP was that we sit with a customer and we sit down to write a test and we go, well, what should it do? And that's kind of when we have that discussion to get the requirements. So I find it really interesting that we've had this, we can't do this because we don't have the requirements to. Now we're going to use AI and we're going to get the requirements and write the spec up front. And I find all of that quite weird, because it seems to me, and I don't know what your experience is, so this is why my question's leading, that back when I was at university and learned about software engineering, a key part of software engineering was requirements analysis and requirements capture, and that was a job of software engineers. It was expected that 20% of the project up front would be capturing the requirements. It feels like over the last 30 years, software engineers got to thinking that that's not their job. It's not part of the software engineer's role. So that's perhaps why they use the excuse that you can't do DTD because we don't have the requirements and the requirements aren't my job. I think it's interesting that we're now coming back to spec-driven and we're going to have the requirements. And I'm curious to see how that plays out, whether or not we'll end up with the same pushback on spec-driven development that requirements aren't the software engineer's job, where I absolutely feel that requirements is part of the job, and it's a major part, and it's a key part to get right, and it's a skill that seems to have been neglected over the last few years. So what are your thoughts on that, Owain?
I guess working in certain environments, I do see a lot of upfront design and requirements gathering. And so I think the best software is well thought out in advance. And we spend a lot of time thinking about the requirements. I do think the requirements are the job of the software engineer. I think planning and designing the implementation is the role of a professional engineer. I think many companies like AWS is a great example where they do have a strong design writing culture. They spend a lot of time iterating, planning up front. And I think that is normally the best way to write complicated large scale systems, is to do a lot of upfront planning. You do need to get good requirements. The one area I think AI can help with those things, you mentioned Agile. I think being able to prototype a working demo very, very quickly, this is where the whole vibe coding thing comes in. I think being able to move much faster can lead to better designs because you're able to test the working software very quickly, find the issue. So for example, when I design something now, I'll often just build the prototype as fast as possible, use it for a while, spot the errors, then go back to the design, but use the kind of the feedback or whatever I learned from doing that prototype. I can do that now that before I wasn't able to do that. And I think that's what's maybe interesting about AI in general. I don't know if that answered your question, John.
Not quite, but let's pull on that. I love Agile for that. And the first time I got to really experience that was sitting with a customer in 2000 and sitting with the people that were going to use this software. And this was MFC GUI. They were going to be sat in front of this UI every day using it. And even then, MFC was quite a hideous library for anyone that's suffered it. I'm sure they remember the pain. But even then, building a C++ with MFC on Windows, having to compile my code, I could still turn that down quickly enough that I sat in front of 20 users with my laptop screen projected onto a large screen, showing them the GUI, having them come over and push keys and drag the mouse back and say, oh, no, I don't want that, move this, and could iterate fast. And that user experience was great. And that evolution of the product was so much better. So that was great, and that's great for Agile. I'm going to push back a little bit on you said that design up front is crucial for large projects, because I have worked on a few relatively small code-base-wise projects. One, for example, was an AI product that we sold to Facebook in 2014. And we spent about a year to 18 months customizing this product for Facebook. Think that the entire code base that we added to the product to customize it for them was around 2,000 lines of code. So pretty tiny. Most of that year was spent in gathering the requirements, getting very clear acceptance tests, understanding the domain knowledge. And I think for one of the main features that we built, the requirement spec was 3 pages. I think I spent 9 months iterating on that, getting it absolutely perfect with the fine detail that was required. So there's an immense amount of writing and collaboration that went into that with them. And that was a fairly tiny thing. But when there are these things that matter and are really important, and millions of pounds worth of value hanging off the back of it, those things matter. And I think a lot of people, maybe outside the enterprise or outside having done some of this non-web-based software, have missed a lot of that.
Yeah.
Wanted to pivot a little bit. I saw a comment on social media, and this is something that I know a few engineers have asked me about in the past as well, saying AI can generate code now, so why don't we just bin all the programming languages? And because programming languages are for humans, why don't we just have it generate code? My answer to that has been, well, it just doesn't work that way, because if we cut out a programming language, we'd have the AI generate machine code.
Yeah.
Where are you going to get the training data from that?
Well, I would also say, how are you going to review that code? So I think it comes back to this idea of, can AI just write all of the code and there's no human involvement? I think that's never going to be the case. I think AI is going to do more of the coding. I think I'm on the extreme where I think a lot of the coding will be done by AI, because I think the models are. I slightly disagree with the statement that AI can't write good code, or like it always writes bad code. I think there's maybe a bit of a myth, I think, where people say that AI slop, it's overused, I think, because AI can generate very good, accurate working code perfectly.
I agree entirely there. I think if it's generating slop, we're back to that old saying from software: garbage in, garbage out. If you are feeding it good requirements, if you're using it well, if you're a skilled engineer, it will amplify what you do. If you're an engineer that produces slop, it's going to amplify your production of slop. I don't think that it inherently is good or bad in that. It's just an amplifier.
I agree with that. I think AI is only as good as the person using it. And I've seen senior engineers have more benefit, in my opinion, from these tools, because they are able to reject the suggestions very quickly. If AI suggests something that doesn't make sense, or writes bad code, they're able to very quickly see that and correct it. Whereas junior engineers are maybe more susceptible to blindly accepting the suggestions. You do need to know what you're doing. I think it comes back to that point that you always need a human in the loop when it comes to these kind of tools. And so, to your point, yeah, you need a programming language because a human needs to understand the code. And you're always going to need that, no matter how good these tools get.
So I wasn't approaching it from that point of view. I agree with you, but I was approaching it from a very different point of view, which maybe I'll explore in a minute. I think I probably want to draw a distinction there, that I wouldn't necessarily say a senior versus a junior are going to be the difference.
Yeah,
I think that the way I'd like to draw the distinction is perhaps that somebody with, I use this word with caution, but somebody with better taste, however you define taste, and perhaps better pattern recognition. So again, both of those things tend to come a bit more with experience, but there are some people that just naturally have amazing taste. Now, I've met one or two 20-year-old software engineers that have absolutely blown me away with the quality of what they can produce. But for most of us, I think that taste and that pattern recognition comes with experience of having seen enough code, having seen enough mistakes, having had to maintain code for long enough in the big enterprise production environments, having seen code that's 20 years old. It's not how we like it, but it works, and it's been there for 20 years, and it's making millions of dollars for the company. So you don't change it for the sake of changing it. You recognize that it was maybe the best that they could do at that time, and maybe these days you wouldn't like that in C++, you'd use something else, but that something else didn't exist 25 years ago when it was written. So that, I think, it's that taste and experience that comes with it, and I think, again, that is so important for being able to leverage AI well.
I completely agree with what you're saying there. I think that's one of the things that I think is most important when you think about these tools, is this idea of taste and still caring about the code. So you can use AI generated code in a way where you're continuously refining it. So you're not just generating the code and going with it. You're continually improving it, using your own taste and your own judgment. And I gave the example there where, you can have AI generate a working solution, but then you can go back and say, well, hang on, this code needs to be improved further. How could we improve the design pattern here? How could we improve the class to be more readable? How could we improve the method names here? So I think that mindset of owning the craft and the code while working with the AI, I think is the key to using these tools really effectively. And I think that what you just said there is the key. It's about taste and about iterating until you get what you want, not allowing the AI to control what's generated. And I think that's how you get successful with these tools. And so I think you're right. It's not a senior junior distinction. It's are you able to iterate and work with these tools and use your own taste and judgment as an engineer?
Yeah. And unfortunately, it does generally, for most of us, take a bit of time and, years in the job to gain that taste and experience. But some people naturally have it. The way I was going with the programming language for AI is I don't think there's any training data that, English to machine code. I don't know how you get that because after all, they are large language models. They're modeling a language. So I don't know how you'd I don't think there is any training data, and I don't know how you'd create a big enough corpus of language to machine code. The other thing is machine code is platform specific.
Yeah.
Whereas JavaScript, it will run on any device that has JavaScript interpreter, for example, or Rust and Go, we can compile to most of those platforms. If you're going to do it to machine code, you now need not just output the JavaScript or the Rust or the Go, you need to output the machine code for each different platform you want to support.
Yeah, I think the point here is that maybe AI generated code is good for certain languages. So Rust is a great example, I think, where right now it's quite hard for the LLM to understand the borrow checker and some of the weird nuances around that language. And I don't think it necessarily understands them very well. So I think
That's interesting.
I think it definitely works better with certain types of Python and TypeScript it was heavily trained on. And I come from a diverse language background. I write Clojure and OCaml and all kinds of languages. Certain languages it's not going to perform as well at because it's not as well trained on them. Although the agents are pretty good and they can learn from the errors that come back from compilers and things, Rust is a great example where I think you do need to understand at a slightly deeper level than just the syntax.
So that's interesting because I've been really quite impressed with how well they cope with Rust, far better than I expected for a newer language. And I have been playing with Gleam recently.
Okay.
Partly because it is so new. I thought this will be a really interesting one to really test the models out. And again, it's definitely easy to find edge cases with Gleam, and very easy to find edge cases and almost down to the day see when the models last collected any data, because that language is evolving fast and the library is evolving fast. So, quite often they'd output something that you can look at the documentation and say, 11th of June, that was deprecated and is no longer available. So that model was changed up to that date. But they did surprisingly well for things I've tested them on Gleam and what I've pushed them to. But again, I think if you just tried vibe coding and I don't know Gleam, I did this deliberately as a bit of fun to learn Gleam and a bit of curiosity to, I'm very cynical about a lot of the claims made. So I was, trying to discover the edges of what can be done and push it. So I was quite impressed at how well they coped. I managed to do several of my coding challenges in Gleam in a few hours for some of them. Now, I would probably have written the code by hand quicker in a language that I know. But for tackling language I don't know and very deliberately writing minimal code myself, I was quite impressed at how well they did cope. So we say there are areas where the language has moved on since their training data, so they struggled. And if you didn't have the software engineering background, you'd probably be hard pushed to get over that hump. But again, I've had enough experience. I've spent literally decades now searching Google if it gets stuck. So between Google and the LLM, I was able to go and get it the right information and say, this is what you need. Here's the latest docs and to move on. So I was quite impressed at how well they do cope with relatively little training data or newer languages.
That's interesting. Another trick that works well is to feed them a large amount. Even though they're not trained on the data, you can obviously ask them to read. I think one of my favorite examples is the training cutoff is often before some of the latest APIs for OpenAI, and you can often just feed it the documentation and it can go and learn how to to use those things. And it might be the same case here with programming languages, where you can just feed in additional guidance or documentation that maybe helps them work well with those models.
Yeah, and it's an interesting area there. There's that somewhat meme response now of you just need to prompt it better,
Yeah.
which comes across a lot of times as a bit of a cop-out. But actually it does make quite a difference, doesn't it? What's been your experience of the value of prompt engineering?
I think the hype word that we hear now is context engineering. So I think prompting matters. I think when you're working with a large language model, ultimately the model and the prompt and the tools available are like the key things. So I think the prompting really does matter, but I also think the context you give it. So I think your job as an engineer working with these tools, again, going back to understanding where the limitations are, they don't understand your preferences. If you ask it to write code and you get frustrated that the code isn't in your style or you don't like the code, it's on you as the engineer, right? Because it doesn't know. So I think the key to using these tools well is to feed them the right context, like you just said. Give them a specification, give them a full PRD describing exactly what you want in extensive detail, give them documentation that they don't have access to. I think that's ultimately the key to making these tools work well. They are only as good as the context you give them, in my opinion.
So there's going to be a lot of people that's going to be a new concept to. As you say, we've had prompt engineering talked about for years. Context engineering has been talked about increasingly over the last couple of months. So a lot of people aren't going to know what the difference is. So how would you explain the difference between context and prompt engineering to people?
So when you're engaging with a large language model, the thing you give it is the prompt. So that's what you ask it to do. But inside its context window or its working memory is a whole lot of other information. So if you were to go into the API behind the scenes, what's really happening is there's an array with all of the messages, the past history, the tools it has available, any other information that's fed to the LLM, and it gets bundled up and sent to the large language model. So the prompt is just a small part of what you send to the API. It actually contains a list of tool calls, of MCP calls, of the past conversation history, of any documents it's fetched in the past. So it has a working memory that builds up over time. And obviously all of these models have a maximum context window. So they can only fit so much information in their working memory at any one time. But the difference is knowing that it's not just your prompt. There are other things that it can see. And what it can see are the past chat history you've had with the LLM, any tool calls it's made. If you're working with an agent like Claude Code, it sees the actual execution of that code and the response from the terminal or the JSON output from the API call. It has that in its context window. Does that make sense?
Yes, that's a good way of explaining it. And what I wanted to pull apart for that a lot of people forget is that if you give it the kind of vibe code prompt of build a website, that's 4 or 5 words, where if you come along and you say, give it that full description as I want to build a website that, I don't know, looks like coding challenges.fyi, it should list 100 coding challenges. They are projects of this. I want it to be based on WordPress, say, and I want it to have a WordPress theme that looks like Docusaurus. You're giving it all that information. And if you, again, just fire off that as one prompt, you've given it one prompt. If you then feed it multiple prompts, you're building up that context, aren't you? And you could copy and paste in there. And we're building up all of that context around it. That gives it way more information to go to work from.
Yeah, and it's the same as if you were working with a junior engineer or anyone, even a senior engineer in your team. If you don't give them the information they need to do the job, they won't be able to do the job. It doesn't matter how senior that engineer. And I believe that these models are world-class at writing code, but they don't have the context that you have. And so a lot of your job is to give them the context. I think they can perform like a senior principal engineer if given the right information, but often we just don't give them the information, so they can't do the job.
And we're back to that old classic software engineering one. I remember in my first job in 1996 getting a bug report that said,
yes,
it crashed.
Yeah, that's it. Yeah.
Where do I go with that? What crashed? What were the steps you take? Yeah, I was a junior engineer at the time, but I was working with a senior engineer, and it wasn't enough context for him to do anything with. It crashed. You need the steps to reproduce it. And again, I'm sure we've all seen that Jira ticket that says, add feature X.
Yes. 100 times. And I think maybe a lot of the criticisms with the initial experience of these AI tools is that they are given relatively little context. They will be over eager and try and solve the problem. But if you haven't given it the context and it does the wrong thing, it's kind of on you as the person controlling this tool. You didn't tell it what you wanted and it didn't do what you wanted. So it's kind of, I think that's a really good analogy, John.
Yeah, it's the exact same as the product owner or the user that gives that poor defect report or that poor requirement. You're not going to get what you want. You have to follow that description and have that conversation and provide that context, whether it's to a human or AI. I've taken up a lot of your time, Owen. We've slightly overrun, so I'm going to leave it there if that's okay. So final question. If people are interested in learning a little bit more about AI engineering and how they can use these tools, how they can build these products, I know you have some courses and support for people. How can they get in contact? How can they find out more?
There's a couple of things that I run myself. So I run an AI engineering community, which is on School. So you can get access to that at school.com/AI engineer. I also write an AI engineering newsletter, which is focused on building systems and actually using AI as a software engineer. And that's my newsletter is newsletter.owenlewis.com on Substack. And the other thing I would say is to do what you suggest, John. I really like your approach of building real projects. I know you've got some challenges in this area. I suggest just really experimenting and building with AI because it's so new. The only way you learn these things is to experiment and build. And so building side projects, I think, is a great idea.
I couldn't agree more. We'll put all those links in the show notes as well for anyone who wants to check them out. All right. Thank you very much, Owen. Been a pleasure.
All right, thanks, John.
I hope you enjoyed that episode of Coding Chats. If you did, please like and subscribe. And feel free to check out these other videos on a similar topic.